We're trying to find the flux through a particular shape that's bounded by a couple lines and a cylinder equation. So it's probably best if we try to figure out how to graph that. So we got x equals 0. That's just actually just going to be this particular region here. Z is also equal to 0, so we're kind of stuck around there. And then x equals 3. Let's find that. It's going to be over here. Okay. Now, this whole x equals 0 thing means that it's kind of like either going to be on the bottom side or the top side of that line, because that's one of the boundaries. And then the cylinder is z equals 4 minus y squared. If I plug y in as 0 right here, then I'll get a z of 4. So that means that this thing has to be like on top of zeros. There's everything above 0 up to 4. And then if I start reaching towards like a y of 2 over here, or negative 2, then this stuff will essentially just start to curl over. And of course, that's just going to connect to the other side because we have that side, and then that's going to curl over again over here in this sort of a 3D shape. And so that's going to be our little cylinder. I think this one goes to 3, this thing goes to 2, negative 2, and here's a 0 as well. So now what we could try to do is solve the flux things. We're actually trying to find the flux through this surface, or volume really. And that's really, again, going back to the divergence theorem, because if we're trying to find the flux, doing n ds, that would be the equation to find flux. You could go through the really complicated calculation, which I'm not going to really explain here, but you could also use the div of f over the dv. So if you have this balloon and you're filling it with air and it's expanding, and you know how big that balloon is and how fast it's expanding, you could probably calculate how much air is being pumped into the balloon to make it expand. That's what that flux thing is trying to say. And we could basically simplify this down into a little bit of an easier equation by using the div f. And remember that the div is an easy equation. It's just going to be ax plus by plus cz, so it's really easy to find out. This is going to correspond to an a, a b, and a c here. So that's just going to be the partial of a. You're going to want to sum all these over the volume integral. And that's going to be 2x minus 1. Then you're going to add, next one will be partial of b. That's going to be negative x. And then you're going to have the partial of c. That's going to be 3. This is over dv. So let's try to figure out which order we're going to want to do this in. We got dx, dy, and dz. Here's the triple integral. And let's look at what we have already. We actually have x equals 0 and x equals 3. So we should use that as our solid numbers on the outside. So we'll put those, let's kind of switch dz and dx. So this will go from 0 to 3. And then we have the z going from 0 to 4 minus y squared. So 0 to 4 minus y squared. And that confirms that we should have the y, that we should have the z before the y integral, because the y is part of that. So then we'll be able to integrate that over here. This one's going from negative 2 to 2, as we can see. Okay, so what we have inside of here is actually just going to be x plus 2. And so now we could try to integrate this stuff. So we'll go x plus 2, integrate that over the z. Well, we can just replace that with a 4 minus y squared. So this is going to be the first integral. It's just going to be like 4x minus xy squared plus 8 minus 2y squared. And then we could try to integrate that over the y. So we'll go 4xy minus xy to the third over 3 plus 8y minus 2y to the third over 3. And we could take this one. This one is going to be symmetrical, so we'll just go from 0 to 2 and multiply that at the end there. So we'll say that this is going to be like 8x, and then we'll have 8 over 3x, and then we have 16, and then we have minus 16 over 3. And if we multiply that by 2, then we'll get 16x minus 16 over 3x plus 32 minus 32 over 3. And we could simplify that a little bit further. So let's try doing 16 minus 16 over 3. That's going to be 32 over 3. This is going to be times an x. And then we're going to add 32 minus 32 over 3. That's going to be 64 over 3. We're going to want to integrate this over dx still. So we'll say 32x squared over 6 plus 64 over 3x. And this is going to be going from 0 to 3. So now we'll say, well, 3 squared is 9 times 32. 9 times 32, divide that by 6. So we'll get 48 plus 64. And so that's going to equal 112. Right on.